All right, welcome to 10.3. Here we're simplifying radical expressions. So objectives are going to be applying the product rule for radical expressions and then applying the quotient rule for radical expressions. So the product rule for radicals. So consider the following example. So if we have the square root of 4 times the square root of 25, well, the square root of 4 is 2, and the square root of 25 is 5, and 2 times 5 is 10. We could do it that way, or we could take and bring the two together and have the square root of 4 times 25, which is 100, and the square root of 100, which is 10. So both ways work. So this gives us the product rule for radical expressions where let a and b be real numbers. The nth root of a and the nth root of b are both defined. Then the nth root of a times the nth root of b is equal to the nth root of a times b. Now, this only works if a or n is the same on both of them. If this is 5 and this is 4, it doesn't work. But if this is 5 and this is 5, then it's going to work. So that's what it means by the same index, that n has to be the same in both of them. All right, so let's see here. It's not going to work. There we go. Let's erase that big line. I don't know what that was from, but all right. Here we go. Now, let's do some examples. So we're supposed to multiply each radical expression. So what we're going to do is we're going to use the product rule for the radical expressions where we bring it under one radical and then do it. All right. So when we do that, 36 times 4. Well, we know that's going to be 6 times 2, which is 12. But what we can do is bring it together and we multiply together. That's 144. And we know the square root of 144 is 12. Now, what about this one? Well, the nth root or the third root of a negative 8 is going to be what? A negative 2. The third root of the 27 is going to be 3, so that's going to give us a negative 6. But if we multiply them together, we get a negative 216, which gives us a negative 6. Now, on these, it doesn't seem logical why we would want to multiply together to get a bigger number to do this. But what happens sometimes is one of these is going to be, close to a square root, but not perfect. The other one's going to be close to a square root, but not perfect. But when you multiply the two together, it becomes a nice perfect square root that you can then take the square root, or in this case, a cubed root or a fourth root. Okay. Now, this is where it comes into play. The fourth root of this, well, we can't do that. The fourth root of that, that's not really going to work. And so what we're going to do is we're going to multiply all those together. The ones on top is going to be 1, then 16 times 16 is going to give us a 256. Well, now the 256 we can take the fourth root of, which is 4. So we get 1 over 4 because the fourth root of 1 is just 1. And so that's that. And so, these two, the top ones, A and B, that would have been just 6 times 2, which would have been 12. That would have been a negative 2 times 3, which would give us a negative 6. But these we can't just do directly. And so we have to do it this way to be able to get to that final answer of 1/4. All right, what about these? All right, so here we're going to again multiply these. So when we multiply them together, we're going to get x to the sixth. Now, if we forget already, x to the sixth, and we're taking the square root of that, that means to the 1/2 power. And 6 times 1/2 is 3, and hence the 3 here. Okay, so if you forgot how you went from here to here, because you have the x to the sixth all to the 1/2, and 1/2 times 6 is 3. Okay, here again, we're going to multiply. So it's going to be 5 times 10 is 50, a cubed, and it's a cubed root of that. And then 50, we can't do anything with that one. That's not going to be anything cubed root. But a cubed, the cubed root of that is a. So we can bring that a out in front, and then we have the cubed root of 50. So now we're kind of seeing more reasons why multiply it out because we can't do anything here, we can't do anything here. But when we put them together, we get a to the third, which we can then take the cubed root of. Same thing kind of goes here. Doesn't look very useful having it doing anything here. But when we multiply them together, what do we get? We get 21xy over xy, and it's the fourth root of that whole thing. And guess what? That xy over xy is going to cancel, and then you just have the fourth root of 21. So see, here it doesn't look like anything will cancel because you have two separate radicals. But when you bring it all under the one radical, our xy's cancel to get it something nice like that. All right, let's stop there and come back for some more.